highest hydrogen bonding. Which one will form highest hydrogen bond?
I don't know, sir.
So if you are going to dip this in water, it's very easy. Hydrogen bonding can form from here. That means there will be two hydrogen bonding. Here it can form from only one side because one hydrogen is there and there is no side. So the hydrogen bonding tendency is primary, then secondary, and then tertiary. The one which makes more hydrogen bonding will be more
Okay, sir,
soluble in
understand.
water. Is that clear?
Yes, sir.
Please do write it. You are going to join the class on Friday, right? There will be a class for D and F block.
Yes, sir. Okay, I'll join. Yes, sir, I'm done.
Very good. Now, see about chemical reaction. So in this chemical reaction, first we are going to deal with basic character of amines. Basic character of amines. So you have to recall about Lewis acid and Lewis base. So Lewis acid is the one which accept lone pair of electron. Lone pair electron acceptor. If someone takes electron, that is Lewis acid, and Lewis base is lone pair donor. Are you getting my point?
Yes, sir.
So the one which donates electron is Lewis base. The one which accept electron or withdraw electron is Lewis acid. And as we know that this amine, basically this ammonia has a lone pair, or this amine has a lone pair, so it can donate electron. That's why it acts as base, because it is what it is basically. It has a tendency to donate electron. Okay, so I'm going to write a reaction. This is your base, and if you are going to react this with acid, it's very easy. You know that this will go in negative, so it will attack on this. It will give electron to it and form a bond in this way, RNH3 positive, and then there will be X negative. That is short. This reaction we have studied in the first lecture. As well as this is your primary or aliphatic, and this is your aromatic amine, which is aniline. So if you are going to react with HCl, again same process. This Cl minus will take electron from hydrogen, so it will have this nitrogen has a lone pair, so it will donate to this, and it will form a salt which is known as ammonium chloride. So it will be NH3 positive and Cl minus. This is known as ammonium chloride, which is also a salt. Please do write it. Do let me know when you are done with this.
Okay, sir. Yes, sir. Done.
Very good. Now see, there are more reactions. If you are going to react this with base, like this salt that we have formed, RNH3 positive and X negative. If you are going to react this with OH negative, then it will form amine along with water and halide ion. H plus will go with OH minus, so it form H2O. Now it becomes RNH2. X negative will be eliminated in this way. So we also know that basic character is directly proportional to plus I, electron donating group, inductive effect plus R, resonance, directly proportional to Kb, that is base dissociation constant, inversely proportional to pKb, which is inverse of Kb, inversely proportional to electron withdrawing group, inversely proportional to minus R, inversely proportional to Ka, acid dissociation constant, and directly proportional to pK, it is inverse of K. Here, problem comes because we see the basic character in gaseous phase as well as solvent solution phase. So I'll explain. First writing. Always remember that this R has plus I. Madhya,
Yes, sir. Good evening.
good evening. So how was your pre-board?
Sir, they were good. I have my book practical exams going on right now.
So we were studying, we have completed preparation of amines. Now we are going with the chemical reaction of amines. And This
Okay,
is the
sir.
basic character. Okay. Aman, are you done with this?
Yes, sir. Finished.
Okay. Madhya, can I change the slide?
Yes, sir.
Okay. Now see, we are going to see the basic character in gaseous phase. In gas phase, the basic character in gas, or we can say vapor phase. So, as you see, if I'm going to give you RNH2, which is a primary, then RNHR dash, which is a secondary, and R like this. Can you arrange this in increasing or decreasing order of basic character? So see, in vapor phase, it's very easy. You can see R has a plus I effect, so it will donate electron from one side. It will, this is secondary, so it will donate from two sides, and it will donate from three sides. That means basically, if you can see, this will be the most basic, then this, then this. This is in gaseous phase or vapor phase. Okay. Problem comes when it is in solvent form, solution form. What does this mean? So basically, in solution form, there is another factor that comes, that is basically steric hindrance. So if I'm going to give you in aqueous state, state, if I'm going to give you CH3 whole twice NH, then comes your primary CH3NH2, then comes your tertiary CH3NH, and then comes your NH3. Now the basic character follows the order 2 degree, then 1 degree, then 3 degree, and then NH3. Am I audible clearly?
Yes, sir.
Now see, why does this happens? In the gaseous phase, it's very easy, 3 degree, 2 degree, 1 degree, because here only plus I effect is occurring, or only plus I effect acting. But here with the plus I, you have steric hindrance as well. Steric hindrance, there will be formation of hydrogen bonding and all. That's why when the R is equal to methyl group, so secondary will be the most basic, then primary, then tertiary, and then comes NH3 at last. In the same way, if you are going for this methyl as a R group, then secondary will be the most, then comes your tertiary, then comes your primary, and then comes your NH3. So in this way, you have to keep it in mind. Because of this variation here, the sometimes basically the solvation power or the steric hindrance dominance, that's why this comes here and then this. So when R is equal to methyl group, secondary will be the most basic. When R is equal to ethyl group, again the secondary will be the most basic. In methyl, you have 1 degree, second position, and tertiary at the third position. But in ethyl, you have the tertiary at the second position and primary at the third position. Please do write it. Let me know when you are done with this.
Yes, sir. Done.
Very good. So if I'm going to ask you a question about this, which one is more basic, NH3 or aniline? What do you think? Madhya and Amin. Which one is more basic?
Sir, NH3.
Why NH3? Is there any reason behind it? See, it's very easy. As I defined, Lewis base is the one which donates electron pair. Donates electron. So there is a lone pair and there is also a lone pair, but this lone pair is delocalized lone pair. That means this lone pair will be busy in resonance with the benzene ring. That's why it doesn't want to give electron or donate to other elements or groups. And it can easily donate its electron. That's why ammonia, this is your most basic as compared to this. Have you got the reason, Madhya and Aman?
Yes, sir.
Very good.
Yes, sir.
Can I change the slide?
Yes, sir.
Okay. Now see, the next chemical reaction is acylation reaction, which is very easy. The next is acylation. Alkylation we have already completed in the previous chapters. So we are going for acylation. Acylation, that means we are going to react amine with acyl halide. So first I am going to take this C2H5 vitaminate. I'm going to take this primary. So you know that this is the primary amine. And if you are going to react this with, I will give you a shortcut also, which is very easy. And if you are going to react this in the presence of base, what will happen? It's very easy. Now see, carbon's electron will be taken by oxygen. So oxygen will have negative charge and carbon will have deficiency of electrons. So this will attack on this. So what you will get, I'm going to write this part for C2H5N and this hydrogen on top and this hydrogen on bottom. Since nitrogen donated electrons, so it will have positive charge. And to whom it donated? To carbon. And then there is chlorine and then there is CH3 and then O negative. This is the scenario. Now what will happen? It's very easy. Chlorine will take electron from carbon. Chlorine will take electron from carbon and nitrogen is the third most electronegative element. So positive charge is unstable. So it will take electron from hydrogen. So there will be deficiency of electron on hydrogen. So it will combine with chlorine and this will give again electron to this. And what you will get C2H5 and now you got NH and then C double bond O Cl and then CH3. So this is your basically amide. What is this? This is your amide in which the name is very easy. N ethyl ethanamide. N ethyl ethanamide. This is your product. So what you need to do, it's very simple. Wait a minute, I just made a mistake. Yeah. So you can see HCl. The byproduct, what you need to do, remove chlorine Cl minus from acyl halide and H plus from amines and combine them together. Then a byproduct will be formed and combine nitrogen with carbon directly. Then you will get it. In this way, you can do this. This is your C2H5 and this is your NH as it is. Now what I'm going to do, it's very simple. ClC, double bond O, and then CH3. I can write this. Now what you need to do, it's very simple. Just remove this hydrogen with chlorine and just add this part. So what you will be getting, C2H5 NH and then C double bond O CH3. Again the same part. Please do write it and do let me know when you are done with this. So Madhya, you haven't given any mock test because I didn't get any paper from you. Madhya. Okay, got it. Okay, very good. Evan, is your practical over?
Yes, sir. For the chemistry, but I have physics tomorrow.
Okay. Very good. If you're done with this, everyone done with this? Madhya, you are also done with this. So this is how primary amine react with acyl halide. Now, if you are going for secondary amine, which is also very easy, C2H5, and you can see this is your hydrogen. I'm going to use this, and if you are going to react this with, I'm writing this as this Cl and then CH3 in the presence of base. In the presence of base. So what will happen? Just remove this HCl and add that. So what you will be getting, C2H5 and C2H5, and then this will be C double bond O and then CH3. So this has a name which is N comma N diethyl ethanamide. So it's very easy, right? And again, if you are going to react with acid anhydride like C6H5 NH2, that means basically this is your primary amine. And if you are going to react this with acid anhydride, it's also very easy. Now what you need to do, just remove, just do this negative, positive, positive, negative. So this negative will be directly connected to this. So what you will get? You will get C6H5 N hydrogen and then C double bond O CH3. And this part will be converted into carboxylic acid. You can see CH3 C double bond O, and with O this hydrogen will come. With O this hydrogen will H plus will go to this negative and carboxylic acid will form. Let me know when you are done with this. Are you done with this?
Yes, sir, finished.
Very good. Now see, can you do this reaction? CH3 and H2 is going to react with C6H5 COC. Please do let me know, will you be able to do it or not? So see, it's also very easy. One of the hydrogen and chlorine will be eliminated. And what you will get? You will get C6H5, C double bond O, and this nitrogen will be directly connected. Hydrogen will be there, and this is CH. Or you can write this as CH3NHCO C6H5, which has a name N-methyl benzamide. Benzamide. And Cl and H combine to form a byproduct that is HCl, which is very easy, right? In the next class, we are going to complete this chapter. Madhya, are you free on Friday? We need to cover one more chapter, that is D and F block.
Yes, sir, I am.
So IST timing, Indian time, 6:30 p.m.
Okay, sir.
I'm going to give you some important questions from physical chemistry, which are very important, repeatedly asked in your CBSE. Please do let me know when you are done with this.
Yes, you're done.
Very good. Now, the next reaction is carbylamine reaction. Carbylamine. Reaction. So basically, this is also a test to distinguish between primary, secondary, and tertiary amine. So if you have, write with me, aliphatic and aromatic primary amine, this is important. Primary amines. If you are going to heating with chloroform and alcoholic potassium hydroxide, that means basically ethanolic potassium hydroxide forms isocyanide, or carbylamines. And basically carbylamines or this isocyanide are foul smelling substance. The smell is foul smell. Also, it's important to note that secondary and tertiary amines do not show this reaction. And this reaction is known as carbylamine reaction, or we can also call it isocyanide test. And is used as a test for reaction is very easy. You can see if you have a primary amine, you need to react this with chloroform in the presence of ethanolic potassium hydroxide and heat it. Then you will be getting RNC, 3KCl plus 3H. Just do let me know when you are done with this.
Done, sir.
Almost, sir.
Okay. Done? Simon?
Yes, sir.
No. Now I'm going to share the screen, another screen. Just let me know, are you able to see this? Yes or no? Madhiha and Aman.
Yes, sir.
Yes, sir.
So either you can take a screenshot, but I want this, you're going to send it back to me, these questions. First, can you take a screenshot or you can write whatever you want? What do you want?
So I'll take the screenshot.
Okay, you have to solve it right now. Okay.
Okay,
Madhiya,
sir.
Yes, sir. I took screenshot.
okay. The one which I am rounding is only you need to do this. Question number 50. Just take the screenshot. Can I change the slide?
Yes, sir.
Madhiya,
Yes, sir.
3 question. Question number 9 and question number 12. These are some important questions from different from different chapters of physical chemistry. Just let me know. Done?
Done, sir.
Yes, sir.
Question number 31 and wait a minute, 35. Yes, 31, 35. How many questions you have now?
Yes, sir. Done.
How many questions? 2,
Sir,
then
7.
3, 7. You have 30 minutes. Wait a minute, I just need to give a question from here. This. Question number 2 and question number 3. Just take the screenshot. Then both of you.
Yes, sir.
Okay, the last question. 7 and 10. Wait. 11 question I have given you, and you need to solve it right now. And tonight you are going to send it to me. No excuses, please.
Okay, sir.
Madhiha.
Yes, sir.
So please do solve it. Are you now free from every practical and pre-board and each and everything? Right?
No, sir. I have one tomorrow and then I'm free.
What you have?
Physics.
Okay. So I have sent this. I had sent this to group, but no one solved. That's why I have to take this here. Okay, no problem. Just solve it, and after solving it, you may leave. Okay. Okay. Thank you. Please do it. Aman, are you done with this?
No, sir. I'm still doing it.
Okay.
So, is it okay if I send it a little late?
Yeah, but tonight.
Okay, sir. I'll send it today.
Oh.
Thank you, sir.